Okay, let's.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to APS Webinars. The title of today's webinar is Relationships Between Educational Outcomes and Poverty. I'm Crystal Bailey, and I'll be your host for today's broadcast. Thank you all so much for joining us. APS Webinars are brought to you as a service of the American Physical Society, connecting you with the expertise of individuals who can offer insight into physics careers, educational programs, and professional development for students, working physicists, and educators. Today's presentation features Professor Michael Marder and will be moderated by Monica Plish. Professor Marder will discuss connections between educational outcomes and poverty concentration based on studies from his home state of Texas. After Professor Marder finishes the presentation, the remainder of the program will belong to you for our question and answer session. Because of the number of people attending this webinar, we are only accepting text questions. So if you would like to ask a question, please type it into the questions panel located on the right side of your screen, and we will address it during the Q&A portion of the broadcast. You may ask a question at any time during the broadcast. We will do our best to cover all of the questions that you submit, but we do apologize if we're unable to cover everything. Finally, a link to the recording of today's presentation will be emailed to you after today's event. You can also find a link to that recording on the web page for this webinar in our webinar archives. We encourage you to complete the survey upon exiting so that APS Webinars can improve its ability to provide you with these valuable services. And so with that, I'll get started. Our moderator today is Monica Plish. Monica is the Associate Director of Education and Diversity at the American Physical Society and is co-PI of the PhysTech project. She is a member of the National Task Force on Teacher Education in Physics and the AAPT Committee on Teacher Preparation. Before coming to APS, Dr. Plish led education programs and developed courses in nanotechnology for her undergraduate students and high school teachers. She completed her doctoral studies in physics at Cornell University. And so with that, Monica, I will turn things over to you.
Thanks, Crystal. So as Crystal mentioned, today we have Professor Michael Marder joining us to talk about relationships between educational outcomes and poverty concentration, again based on data from Michael's home state of Texas. As Associate Dean for Science and Mathematics Education in the College of Natural Sciences at University of Texas in Austin, Michael Marder is co-founder and co-director of UTeach, which is the university program for preparation of secondary math and science teachers. Michael helps direct the national expansion of UTeach and is studying the influence of poverty on educational outcomes. Michael is also involved in a wide variety of theoretical, numerical, and experimental investigations, specializing in the mechanics of solids, particularly the fracture of brittle materials. And Michael, I'll turn it over to you to do the presentation.
Thank you, Monica. Thank you, Crystal. And thanks to all of you who have joined. Perhaps we're looking at the future of education here. Rather than staring at your faces, I'm staring at a screen. It's something we may all need to start getting used to. What I'm going to do today is to give you a little tour of some of the data that I have assembled over the past several years, trying to connect educational outcomes to poverty concentration and other school factors. It started because I was helping really wonderful students graduate from the UTeach program. They were going off into the schools and they started to tell me stories. The stories had a certain sameness to them, stories about the difficulties that the students had, particularly in schools of high poverty, in fully implementing the idealized scenarios that we sometimes laid out for them in the preparation program. And as UTeach spread across the country, began to feel more and more urgent to understand the relationship between what we were telling these wonderful idealistic people and what was actually happening out in the schools. So alongside preparing students to become teachers and performing fairly conventional physics research over the past several years, I've been gathering a lot of data. Now, if there's one single thing more than any other that the data told me, it was a very simple phrase that I will now share, with apologies to those in biology who provided the original version, which is that nothing makes sense in education except in the light of poverty. I want to keep that sentence in mind, not because I think it describes a necessary and inevitable link, but simply because the data as they are in our country right now indicate that unless you take this into account, it's very difficult to understand some of the things that are happening around us. And I think it will also be very difficult to devise appropriate and correct solutions. Now, before I get going on the K-12 context, I want to make a remark on what some of the things I will discuss might mean for us. I don't know who all of the people are who are in the audience. If this were a room, I would ask you, and I can't. But I'm going to presume that some of you might be at universities. So let me just give you a quotation from the New York Times on April 19th, not too long ago. This was a David Brooks column about our jobs, college. This is an unstable situation. At some point, parents are going to decide that $160,000 is too high price to pay if all you get is an empty credential and a fancy car window sticker. One part of the solution is found in 3 little words: value-added assessment. Colleges have to do more to find out how they're doing. So the point which I would like to emphasize here is that I'm going to move on to the K-12 context and talk about the efforts to try to assess the teaching workforce based upon test scores. But I think we should all care about it because this is soon coming to us in one form or another. We don't yet know the form, but I think evading it is probably not very likely. So now a quick review of some of the features of evaluating teachers based on test scores before I begin to look at the educational outcomes that are related to them. This, I think, may be interesting to us just as physicists. I think the mathematics is interesting, and it's also always interesting to see mathematical ideas as they begin to work themselves out in the world. Statement you'll read commonly in the press is that evaluating teachers is very important. Here's a characteristic statement. We know that having an effective teacher 3 years in a row can literally help us close the achievement gap for poor students and students of color. I'm going to look at a little of the mathematics that lies behind that claim. Have you all got your pencils out? Are you taking notes? Because here's the formula, and yes, there will be a quiz at the end. This is a characteristic formula for value-added scores. Over on the left-hand side is the score of a student, and the score of that student is expressed as a linear function of the student's score the previous year, demographic characteristics, for example, of their classroom, of their school, a contribution from their teacher, and then an error term for everything that doesn't fit. These formulas are starting to be applied in real life, in real practice, to very large numbers of teachers to try to figure out which of them are good and which of them are bad. I want to, because I think some of this may be coming to us, I wanted to say a little bit about it and give you my take on whether this technology is working very well yet. And I'll show you 2 things. The first is a plotting of data from a random controlled trial conducted in Los Angeles by Kane and Steger. It's a really impressive piece of work. Teachers were randomly flipped between classrooms. Several years of test score data were taken to try to figure out the baseline upon which teachers should be judged. Then they were randomly flipped between classrooms. Computer programs were used to try to predict the differences in student scores between the 2 classrooms. And the measured differences in the final year were compared with predictions. So about 2/3 of the time, actually, the computer predictions were bang on, did very, very well. But 1/3 of the time, the predictions were off. And the degree to which they were off was really rather far. It's customary, although not necessarily completely convincing, to express the scale of test scores in years of learning. And if I just use conventional scales for that, then the error in years of learning could be up to 5 years. So looking at this result of a random controlled trial, I would be a little uneasy about whether the computer programs trying to figure out who are good teachers and who are weaker teachers, whether that technology is really fully at the point where it's ready to evaluate individual teachers. But the world is not stopping. Those of you who live in New York probably know that a relatively short time ago, New York newspapers filed a Freedom of Information Law request and got value-added scores for all the teachers in New York City, and there followed newspaper articles like this one. This was the front page in the New York Post in February. When it comes to teaching math, she's a 0. The teacher is named. her score was said to be 0 with a 0 margin of error. And I won't go on reading the article. I think you get the basic point that not only are these formulas going to be applied, the people on whom they are used are now going to be subject to public display. I actually looked up her scores for the previous 5 years. They're shown here over on the left-hand side. All of this was available in the Freedom of Information Law request. And frankly, I can't figure out how you can get 1, 2, 3, 4, 5 years of non-zero scores and then have it show up as a 5-year, multi-year 0 with 0 margin of error, which is what the state reported. So I'm already a little concerned about the possibility of results in this methodology, which from a technical point of view are a little hard to explain. But there's something else I've noticed which I'm going to share with you before getting on to some other topics, which I found even more interesting. And it is the following. If you look at the formula that is used to evaluate teachers, the dependence on the prior year test score, which here is theta, is just a number. So the prior score of the student is treated as being related to the current year score with a straight line. I've wondered for some time about what impact that mathematical assumption, which I think most people would pay little attention to, could have on the final results. And thanks to the New York release, I can check it a little. Here's what I found. So first of all, I've just plotted for the New York City results the average score change of students versus the pretest score. So it's pretest score on the horizontal axis and average score change on the vertical axis. According to everything I've seen in case after case, this is not fully a linear relationship. There are always corrections to the linear relationship. And in fact, if you just look at it and imagine subtracting a straight line, you would expect the corrections, the error, to be U-shaped. So now I look at the average value added of all the New York City teachers and look at it versus pretest score, and lo and behold, it is U-shaped, just as one would expect if something that's very important is the difference between a straight line and an actual nonlinear relationship. It looks like a smile, and I'm going to propose, so slightly tongue-in-cheek, that we dub this as a systematically mistaken inference from linear estimators. But there it is. There's the smile. So this is what we're in for. We've got groups that are willing to put us in the papers with technical evaluations of our teaching that are based on extremely complicated formulas that few people other than physicists and economists and a few applied mathematicians are likely to understand. I'm presenting this right at the beginning because I feel some urgency in letting as many people with technical qualifications know that this may be coming, because I'm not sure who else will be in a position to raise questions about it. And as I said, the next people may be us. Now, I'm going to give you a sampling of data that I've assembled in a number of other contexts. I heard before the session began that we have a question and even a participant from China. So in just a second, in fact, I will even have a shout out to our Chinese listeners. I want to start with a very frequent claim that's made about the United States standing. Among 30 developed countries, the United States is ranked 25th in math and 21st in science. And there's a first rapid thing one can say about that, which is it's true. If you check the data sources that lie behind that, it's absolutely accurate, and I'll show you the sources in just a second. In fact, I think you can make the case that things are even somewhat worse than those rankings indicate, and here's a plot that compares United States students to Chinese students. This is an article from about 3 years ago that appeared in Science, looking at beginning physics students in the United States and China. This is before they've taken the freshman physics course, so it's an examination of what they've learned in high school. This is, I believe it's FCI that's being examined in this chart, course concept inventory, and the Chinese students do so much better on it than the US students that the peaks are not at all overlapping. In electromagnetism, where I believe the assessment is now BEMA, basic electromagnetism assessment, the peaks are, again, almost completely non-overlapping. One might ask what the reason for this is, and you could come up with all sorts of hypotheses. Chinese students are just naturally smarter. The teachers are much, much better. I think before those hypotheses get too much weight, maybe the most important thing to recognize is that the default Chinese curriculum has students taking physics over 5 years, whereas in the United States, only a third of students get physics even for 1 year. And many of us know that of those, only about a half get it from someone who majored or minored in physics. So I would say that the most plausible explanation of the huge gap between these two peaks is that students learn a subject better when they've had it than when they haven't. Now, the data on which the claims rest that the United States is nearly last in the developed world usually come from Pisa, the Program for International Student Assessment. And so I'm going to show you some of the data there. The claims that we rank very low are absolutely correct. ExxonMobil right now is running ads that feature our very low standing in Pisa, and I think what they say in those ads is really completely accurate. Here I've reproduced them. The United States, this is from 2006, and one can check it also in 2009, either for well-off students or low-income students, is at the end of a long, broad plateau that places us behind most of Europe and many Asian countries. Now, there is another way to look at it. I said at the very beginning that one of the main lessons in trying to interpret educational data is to at least think about putting them in the lens of poverty, and I'm now going to do that in 2 different ways. One of them is through data assembled by UNICEF that categorizes countries according to child poverty after taxes and transfers. So I put child poverty after taxes and transfers on the horizontal axis, and PISA enables one to put U.S. schools divided into 5 quintiles onto the same plot. So at the very top are U.S. schools in which only 0 to 10% of students are eligible for free and reduced lunch. It takes a little bit of calculation, but not much, to estimate that essentially there's no child poverty in those schools. And we do a little bit better than Finland, which is that country which, through taxes and transfers, has secured the lowest rate of poverty for its citizens. And in fact, if you read blogs and Twitter posts, you will find the claim that after controlling for poverty, the United States has the best schools in the world rather than some of the worst. And those claims are based upon this plot where you can observe that the United States schools, disaggregated by poverty, form a line above countries from Western Europe. Now, a question you might naturally have is whether that holds up when you go and disaggregate these countries by poverty. That's not so easy to do, and I haven't done it perfectly, but here is my best attempt to do it. So within the PISA data set, this is now data from PISA 2009, there are 6 income groups, and so I've just plotted bars for every country with a mean score that goes from the mean score of the lowest income group to the highest income group, and I did that for as many countries as I could. I put a bar for the United States, which is based on the free lunch fraction, and it's not quite apples to apples, but I think it's reasonably close. What you can see here is that the United States is not alone in having very large spreads according to poverty. When you look at other countries and the way their students are spread out, some of them really do seem to be doing better. Germany, the students are equally spread out, but they're just shifted vertically relative to us, and their wealthiest students are doing better than our wealthiest students. So it's a slightly more mixed story than the previous plot, but it still does indicate that unless one pays attention to poverty and disaggregates according to it and thinks about its consequences, the chance of understanding the rankings and positions of countries goes down. I'm going to shift over to the United States and some of the claims that are frequently made about educational outcomes. One that's made very commonly is that the United States test scores are flatlining. If you just look up flatlining, I think you should be able to find newspaper articles in which this claim has been made. And the best source that one could rely on for this is the National Assessment of Educational Progress, or NAEP, which is also known as the nation's report card. It's a very professional exam. It's been run across the country since the late 60s and in the current form since the late 70s. There are actually 2 different versions of it, and I'm going to be referring to data from both. Let's have a look at 8th grade mathematics scores to begin with. So what I'm about to show you is going to be every state in the country. So on the horizontal axis here are all states. Let me just get this queued up and started. every bubble on this chart is a state. So that's California, and that's Tennessee. Free lunch fraction or poverty concentration is indicated by color coding. The total number of students in the state who are in school gives the size of the bubble. On the horizontal axis is 8th grade mathematics for better off students. Sorry, can't do 12th at this level of disaggregation. The data aren't there. On the vertical axis, 8th grade mathematics for low-income students. So the way this works is the following. I'm showing you the data for the year 2000. And now I'm going to turn on time and let time evolve. And you'll see from 2000 till 2011 how U.S. students did. If they go to the right, that means better off students are doing better. If they go up, it means low-income students are doing better. And lo and behold, for every state, everybody's doing better. Now, even that little one trailing behind, who's that? Well, that is District of Columbia, Washington, D.C. Let's look at some other states. There's California, and North Carolina, Ohio, Kansas, New Jersey. Texas actually has the highest scores for low-income kids and the best for well-off kids is Massachusetts. The main thing showing this plot illustrates, and I can make the data available to all of you and you could view this Google Doc for yourself, is that the scores have really not been flatlining. And to bring this home even further, let's take a look at long-term NAEP, which I've now disaggregated by white, Hispanic, and black students, looking at mathematics scores for 9-year-olds, 13-year-olds, and 17-year-olds from 1978 till 2008. Describing this as flatlining I don't think is accurate. You'll notice that between the age of 9 and 13, or between the age of 13 and 17, the typical number of points that students gain in any given category in any given time period is about 40. So I'd calibrate this by saying that 10 NAEP points corresponds to about a year of progress in school. You can see that, for example, Hispanic students have gained so much that by 2008, they had almost the exact same score that Hispanic 13-year-olds. The 9-year-olds have gained the same scores that 13-year-olds had back in the late 70s. That's really pretty remarkable progress. It's been comparable progress in middle school, and the one place where things seem to have stalled out is high school. There were gains and slower gains through the 80s, and then since the 90s, it doesn't look as if things have gone up very much. So if we look at these data, it's a mixed picture. Elementary, middle school making progress, stalling out in high school. I'd say this and many other things point to that as a primary problem. Another thing that's very much a part of the national discussion is the role of unions. Steve Jobs specifically singled out unions in a speech in Austin a few years ago, saying that their schools have become unionized in the worst possible way and that this is just off the charts crazy. So claims like this you can actually investigate. You can just look to see whether there does seem to be a correlation between whether teachers have collective bargaining rights and school performance in various states. There really isn't much of one. I'm looking both at well-off and low-income students in NAEP mathematics averaged over the period 2003 to 2009. I don't see much of a correlation there. Perhaps if you stretch, you can find one, but I don't see it. The red and the blue are just insensibly mingled. But I think there is an explanation for the story that costs are doubling, and scores are flat. And let me show you that. So I'm now showing you again every state. State of the bubble again, there's California. And on the horizontal axis, however, I'm putting 8th grade NAEP mathematics for low-income students. And on the vertical axis, I am putting total cost per student in 2009 dollars. So let's look at money versus performance. The lowest cost state is Utah, and Arizona is also quite low. That's back in 2000. I've also indicated teacher bargaining status, so you can look at the whether teachers are bargaining or not, whether unions are strong or not. And as before, the total number of students in schools sets the size of the bubble. Let's set things off and see how they progress in time. So we know that the bubbles are going to move to the right because students are getting better, but there are also states that are moving up pretty strongly in cost. In fact, there are 3 that are really quite far above the rest and rising, and there's one that just jumped down. What are they? District of Columbia, New York, and New Jersey. So the message that I would draw from that, there's still Utah and Idaho, and Texas is surprisingly surprisingly low. It's remained almost flat in real 2009 dollars over the period 2000 to 2010. So the message I would draw from all of this is that the complaints about scores flatlining and costs doubling may be very heavily influenced by the fact that the media and policymakers are in New York, New Jersey, and the District of Columbia, and that it's a local story which is going national, but doesn't really necessarily describe the rest of the country. I'll show you some sampling of other data. In a few minutes, I'm going to stop for questions, but I do want to hit on some of the high points of the extremely interesting reforms that are going on around us. One of them is the conversion of schools and the use of public school dollars for charter schools. There are movies about this. There are many that are opening up all over the country, several new ones opening up here in Austin that are very interesting. A lens that I'm going to view this through is a measure of college readiness. I'll show this for Texas, and I'll try to do the best I can for a number of other states, although no two states have the same thing. Here in Texas, the Texas Education Agency records for every school the percentage of students who take the SAT or ACT and get 11, 10 or more on the SAT or 24 or more on the ACT. It's not that high a bar. In fact, it's below the entrance requirement for certain specialized science and mathematics schools to get into high school. It more or less at research university would correspond to the line below which a student might need extra assistance in coming in from high school. I plotted all the schools in Texas versus poverty concentration, eligibility for free and reduced lunch, and I've color-coded by the number of minority students, which is Black and Hispanic students as a fraction of the total student population. And you can see that this college readiness measure, there is an extremely sharp dependence on poverty concentration, with something that's particularly surprising, the near complete absence of any schools above the 20% line. Now, the next thing I'm going to do is I'm going to highlight charter schools in Texas. They're drawn red. And what you see here is that almost all of them actually are on the horizontal axis. At least in Texas, the majority of them are actually not even aiming for college readiness. They will often call themselves rescue schools, which means they're pitching themselves as places that students go when they're about to drop out of high school and not graduate at all. There's a number that are really pretty good. There's a good one up here, a number down here. These are famous ones you've heard about: KIT, GUESS, IDEA, and they are on the upper end. It's true of the envelope of public schools, but they're not radically changing the relationship between poverty concentration and college readiness as measured by taking the SAT or ACT. And I should say the participation rate at these charter schools is typically quite good. Let me just show you a sampling of similar data from some other states. Here are the charter schools of California. Now I have mean SAT score on the 2,400-point scale versus poverty concentration. There is a charter school that stands out. I believe it's the Croix School in San Diego. Here's Florida, looking at their highest level of performance on their own internal mathematics test, which is the best I could do. Their charter schools are scattered amongst the regular public schools. Here's New Jersey, where many of the charter schools make a lot of national attention, and yet theirs in New Jersey Advanced Proficient Mathematics are scattered at the bottom near the x-axis, again, not breaking the pattern of the regular public schools. And in the case of New York, I settled on New York Regents B, which is a college preparatory mathematics exam. Here I could only find data for 4 charter schools, and they are ranked rather low. These large bubbles up here are the famous New York magnet schools that we know about: Stuyvesant, Bronx Science, and so forth. So the bottom line is that the charter schools are making, certainly making a big national impression in their attempt to have students of poverty become ready for college. And yet, so far as I can tell by examining data, they are not typically doing a much better job than regular public schools in achieving that goal. And if we're going to solve it, we're going to be meeting in a cooperative way to be looking for other solutions. Now I have, as you can see in front of me, a whole other pane, which is full of all kinds of data from Texas, which I actually know in the greatest detail. But we have, according to my watch, actually reached the point at which we said that we would break for questions. So rather than continuing for the next 2 hours as my 1-hour webinar, I think I'm going to break right here, see if there are questions, things people would like me to go back and cover in greater detail, whether there's some things I was about to go forward and look at that would be of interest. And so I'll turn things back over to Monica to moderate that.
All right, Michael, thanks for a very interesting tour of the data so far on educational outcomes and poverty. We have a few questions, so let's just start with, there's a question sort of on the equation that you showed at the very beginning on value-added calculations. And a question from one of the members of the audience is, are there publications you can point us to that reveal, for example, how economists and others have arrived at this formula, and presumably also why it's presumed that it applies in this situation? Additional comment from the participant that it doesn't seem to make sense.
Well, this is part of a very long tradition of linear modeling. The community that, there are several communities that have been developing these sorts of linear methodologies for a long time. I don't know whether the roots are more deeply in economics or education. A lot of the people applying formulas like this right now with the greatest eagerness and inventiveness are trained in economics. Some of them are trained in statistics. Some of the names associated with the development are Sanders in Tennessee and Hanushek, and from, I believe, originally from Texas, but now at Stanford. I'm not sure what I can say in words to justify this, since I'm mainly occupied with questioning it, but there certainly is a large and very smart community of people using formulas like this. The idea is that there are many, many factors that can influence something like educational outcome. There can be the balance of students in the classroom, the prior scores, the overall environment of the school, and you would like to take all that into account. And there are many, many things, and it's very hard to keep it all straight in your head. So you come up with a great big linear model and lots of coefficients which you fit to it. And I don't completely understand why it's so customary not to go beyond the linear order, but this appears to be dominant in any equation I can find published. Maybe the most famous formula is the one out of Tennessee. I believe it's called EVAS, and that, I don't know what's in it. I have not been able to find it published. It is one that I think states are using or being advised to use in evaluating educational outcomes. Taylor expansion of any function is locally a straight line. So if you want to account for variation, start with a straight line. The more parameters you add, the more trouble you can sometimes run into with the model. And so you want to have a balance between the accuracy of the fitting functions and the number of free parameters you leave around. And so there's a tradition of having lots of parameters, but stopping at the linear order. Something else I should say is that a lot of the models are hierarchical. So the coefficients are determined, first of all, a linear model is done, for example, for a school or for a district, and then some of the results from that are used then to make estimates on a statewide level. So it can get to be mathematically a pretty elaborate process, but for me, it's certain very simple things that happen that worry me, like just using straight lines for functions which, when I check them, don't look straight.
So a couple more questions here. One about, there must be some schools in high poverty areas that are doing very well. And the question is, what are they doing differently? Okay, let's check.
And I could even find you quotations along that line. So I have many, I know the data best in Texas, but I'll go back to something I showed, which is, and I could show you this plot. I realize this is 2009. I could show you this, I do have it for 2010. It'll be a few minutes to prepare it. I've also prepared it for 2011. I had it going back, I think, to 2005. It's college readiness criterion. They're above 80% poverty concentration. There are no schools in Texas where more than 20% of the kids are ready for college by this college readiness measure. So the idea that surely there must be some that are doing well isn't borne out. I started hunting across the whole country looking for schools that were doing really well. And criterion would have to be that they would be schools that have a high poverty of concentration, and they probably shouldn't be just completely selective admission. Maybe the closest I've managed to find are in California and Massachusetts. In California, I showed you already one which I highlighted as a charter, but I don't think we need to see that again. It's the Croy School over here on the right. It's not radically, but I mean, it is better than the others at this level of poverty. It's not competing with those at the upper end of the income scale. And I've gone through more states than I'm showing here. I looked at Massachusetts recently, where there's a few schools on the state exam that are doing fairly well, but still do not manage to escape a fairly tight curve for the SAT. I already showed you Florida. I looked at Louisiana, Connecticut. Give me a state. I'll check it. Because of No Child Left Behind, data like this are available. Now, no two states at the upper end of high school have the same measure available. So I'm hamstrung by that. But one can at least do a relative comparison and ask whether there are schools serving a high poverty concentration doing very well. I don't find them. I find this intensely frustrating. How are you supposed to emulate what you can't find?
So actually, let me just throw in one of my own questions here, which is, so what do you say to people who say, okay, yes, there's a strong correlation there between educational outcomes and, say, poverty concentration, but how do you know poverty concentration isn't correlated with something else, such as, you know, maybe the high poverty schools have teachers that just aren't as effective, and, you know, perhaps that's actually, you know, the factor we should be paying attention to?
So I would have two responses to this. One is that the best data I've seen on the distribution of academic capital among schools is Jennifer Presley in Illinois, and she did do a fairly consistent job of showing that in Illinois, high poverty schools have teachers with lower levels of credentials. When I checked that in Texas, I haven't found it. That is, with the data available to me, which were just not as good as what she had in Illinois, I haven't been able to find a really, really huge dependence on the quality of the teachers. Even if that were the explanation, it's still useful to plot things in this way, because the poverty concentration is still tightly correlated with it, and it's still something to take into account. But another argument I've had, which isn't completely convincing, either to me or probably to you, would go like this. If by simply assembling a really crack collection of teachers, it was possible to have a high poverty school reach exactly the same level as a regular school with no other interventions, then surely there would be more examples of schools at the high poverty end that look like schools at the low poverty end. There are schools that have hired a lot of graduates of the program I run, UTeach, and they are working exceptionally hard. They're doing all sorts of wonderful things. They have not yet provided a school which breaks all of these patterns, although it's still somewhat early, and I have hopes for some, particularly the charter schools that emphasize that they're not going to make any excuses and they're going to do everything in their power to hire really great people, including one in New York City that's now paying 5-figure salaries to teachers. There should be demonstration cases if the teacher quality argument were by itself sufficient. So I am completely for improving the quality of teachers. It's what I work on a lot of the time, every single day of my life. But looking at these data convinced me necessary, not sufficient.
All right, so I think that'd be a good point to return to further on. But let me get to a couple more questions. One question is, what do you think about the strategy of paying school students for doing something such as reading a book? So, for example, $2 per book, or paying students for getting a higher score on a test.
Well, I'm actually, I don't know all that much about it, and yet I'm associated with it because the National Math and Science Initiative, which is one of the big partners that has helped replicate UTeach, which the program I run also runs the Advanced Placement Teacher Incentive and Training Program, which pays students and teachers in order to take and pass AP exams. In that particular case, and they focus on high-poverty schools, I have looked at a lot of the data from that, and frankly, there have been such high leaps in numbers of students taking and passing AP exams in cases where that's put in place that I find it hard to argue with. Whether this always happens, I don't know. I know that the arguments about this have to do with extrinsic and intrinsic motivation. I'm not as worried about those as other people. I mean, a lot of us are working because we think that because of what we do, we may get a job or a promotion someday. Money's always been very important in American society, and so I'm probably less worried than most about this. But I would think it's necessary at least to check whether some of these things actually perform as promised.
All right, another comment from somebody is, what is the software used for doing your graphs, or at least one of them? I don't know, Crystal, if you saw when that comment appeared.
Yes, it was the animated graph with all the little bubbles moving.
The bubble. Okay.
Right,
so
yes.
That's courtesy of Hans Rosling's son, I believe. If anyone here doesn't know about gapminder.org, you should go there. You can download the application, which works on PCs, or look at their graphs on the web. This was inspired by Hans Rosling, who was the first person that I know of who created plots that look like this. And I think the software was written by his son, but then Google took it over. So you can get these moving bubble charts, and I will go back. I have many of them scattered around here. You can go and do a Google Doc in one of their Excel knockoff charts, and then there's a motion chart option, and you can prepare this as a motion chart. What I did for this presentation is I just did a screen capture of me running a motion chart, but the real thing is even more fun because you click on it and you run it, and then you can mouse over the bubbles and see what they are. You can change the axes and do many other things. There's a specific format in which you have to place data in columns that then lets you get these really cool animations. It's all free, and anybody can do it.
So you did this, just to recap, you did this in Google Docs, and then you used motion chart?
Yes, that's correct.
And then you did a video recording. Oh, that's very cool. Yeah. I'll have to check it out.
Yeah, it's much more fun to do it yourself than to see the video recording, though.
Yes. So another question here on whether you have looked at any correlation with the English ability of students. You know, a comment that recent immigrants are more likely to be poor, and the parents are not speaking much English, and so their children will also be behind in their English knowledge.
I should look at that more. I haven't so much. I have disaggregated by ethnic groups. In Texas, there's a very large Hispanic population, and so this phenomenon is certainly entering. And Texas does, well, every school is required to keep track of English language learners. So that's a variable I should actually, I should pay more attention to. I think we'll find that it is also correlated with poverty. Minority background is also correlated with poverty. These things are all connected. And I'm not, by focusing on this one variable, I'm not implying that it's not connected with other things. It clearly is.
All right. So a question, going back to the data on expenditures per student by state. The spread, the comment here is the spread seems rather large. And the question is, is there any data to justify the states that are spending much more than average and not getting above average test results?
Well, I've got, this is another motion chart. Actually, this is even a slightly out-of-date version. I was updating it this morning. And so I've put in purchasing power parity lines, and I've also put in some columns that have to do with the number of adults per student in the state, because there are very wide salary differentials necessary just to get people to go into various professions between different states. I mean, from Utah to California, I believe the differential is enormous. So I think there are many things here that require some specialization to understand, and I don't claim I'm an expert in all of it. I think in the case of New York and New Jersey, accounting for past pension obligations is a piece of the cost. The high cost of living, particularly in New York City, is a piece of the cost. Taxpayers are rebelling against these costs quite independent of that. So I think if you want to probe into this, it gets rather complicated rather fast. And I did find it really very interesting to see that there were such wide differentials. And I can't tell you immediately why exactly it is that New Jersey is that much more than Texas, or why it is that with California and Texas spending almost exactly the same per pupil, even after adjusting for purchasing power parity, California ends up with nearly half the adults per student that Texas ends up with at the end of the day, and with much lower student performance.
So I'd like to throw in a question of my own here, which is around teacher preparation programs.
Yeah.
You know, so given that, you know, there's such a strong connection between educational outcomes and poverty, how should those of us who are very closely engaged or somewhat engaged in teacher preparation, how should we change what we're doing, or how should we react to this? You know, do we throw up our hands, or try to keep doing our best, or how do you think about this?
Okay, I'm going to bring up, if I could remember where I put it, there it is. I think the last slide I was going to show, because it may at least illustrate some things that have to do with this. This is something I've been thinking about in the last couple of weeks and trying to assemble some additional data on it. I showed you that it's fairly easy to demonstrate that poverty concentration is very highly linked with student outcomes. And you can look at many measures, many states, and find that the correlations are very tight. However, this doesn't prove that there aren't other things that are even bigger. And I alluded to some, but I'll now tell you what I think the main influences are on how students do. And this is my best attempt to summarize a lot of different things, and I'm not sure that I can really nail it all down, but here goes. So one of the things that I think makes the physical sciences special is that we have this notion of perturbation theory. And one of the ideas of perturbation theory is that you really need to pay attention to order of effects. And if you want to understand a system, start with the biggest. Try to figure out what the biggest one is. Get that one right. Probably going to have to do it rather carefully. And then you look at the corrections. And for the really biggest ones, even fine adjustments of how you treat it might turn out to swamp some of the other ones that come along further down the line. So my assessment would be that really the biggest thing affecting U.S. students is whether they have classes available in certain subjects at all. The comparison of Chinese and U.S. students, where the U.S. students are ones who probably barely had physics if they had it at all, that's just an enormous effect. After that, if you want to get technical and ask what governs score gains of students, very clearly in all of the data, it's their prior score. Where you started that governs not just where you go, but your gain. The lower you start, the bigger your gain. This is huge. You have to compensate for it very well, or else everything that you do later in controlling for various factors doesn't turn out very well. And then I would put poverty concentration after that, and then teacher characteristics after that, just in terms of the magnitude of the effects as I look at them in a wide variety of data sets. So what this says to me is that if what we're doing when we prepare teachers is just having good people who go into those subjects where students aren't getting instruction, we're doing something that's an unadulterated good. And while yes, we should be worrying about everything else, we're already addressing the zeroth order effect, and we should keep that in mind when people start asking us questions about the second order stuff. And then the next thing that's going to affect what they do are going to be details of the composition of their classroom. and we may have to protect them here, because I don't know if the mathematical formulas being employed about their effectiveness are going to treat it right. They could be working their hearts out and really doing wonderful things, and depending on a small number of fluctuations in exactly who's in the room, it could look very different. So I think we need to figure out a way to protect them from that. And then we start getting to the things such as the substance of how we prepare them to work with a wide variety of children. Within UTeach, we make sure that the early teaching experiences are all in schools serving low-income kids. It's not that we oppose our graduates going off to teach somewhere else, but we want to be able to say that we've prepared as best we can all of our graduates for that, so that they are not taken aback by the conditions of schools with high concentrations of poverty. They're familiar with them. The surprise factors are taken away, and they spend a lot of time around experienced teachers who have done things very well with a very wide variety of students. So I do it in terms of perturbation theory. Let's get strong people out to subjects with high need. Most of the STEM subjects are of that sort, particularly physics. Physics is arguably the highest, it's one of the highest need subjects in the country right now. I think if we're preparing physics teachers, we should be proud.
I was going to say the American Association of Employment and Education actually ranks physics as #1 in terms of the teacher shortages for disciplinary subjects.
Yeah, I've tried to do my own estimates of it. That's what I got to. So anyway, that's my take on it. Within UTeach, we can't demand that students go teach in high poverty schools, which is something that sometimes people ask about. But we can try to prepare them for it. I view it as still an open problem, though, for all of us. What really are some of the best things to do? I don't think we fully know. Like most other people, I have some opinions on that. And the graduates who come back and tell me about what they've experienced have a lot more. The master teachers who work with us in UTeach, many of them achieve really marvelous things, national recognition for what they accomplished, and I think their words carry a lot of weight. So it's not as if we're out of ideas, but I don't think we yet fully have the answers.
So a question building on this particular slide, wanting to know what is the difference, I guess, numerically between the first, second, and third orders. And if I can tack a question onto that as well, is this, are these effects that you have, these perturbations, are these effects that you have actually measurably observed in the data, or is it your sense of how these things come into play?
The very first one, the absence of instruction, I'm not quite sure how to measure it, because when students don't have something, particularly in high school, we tend not to test it at all. So there I'm on shaky ground. We're almost in it stands to reason territory. It stands to reason that you're not going to do well in physics if you didn't have physics. And I welcome suggestions on how to do somewhat better than that. The end-of-course exams that some states are starting to do, and Texas is amongst them, might give us something. But some of the others I can document, and I have some of the data here. So I can document here that score changes are bigger than poverty concentration, and also the degree to which an exam is high stakes for students matters a lot. So I have averages over many years of student scores. Student score changes in Texas as a function of grade, poverty concentration in the school, and prior score. And it would take probably would take anybody here some time to figure this all out. I put a number of bars down below to indicate the scales of things that come out of these plots. So characteristic standard deviation for this exam is about 20%. That's this bar here. If you look at the biggest changes from the bottom of some curves to the tops of others, it's a bit larger than that. It's nearly 20 points. So replace low-income 9th grade A students with a class of wealthy 11th grade F- students. The teacher, given that dealt that hand, should expect to get an enormous gain over the previous year. And then we head on down looking at what you would expect just statistically to be student score gains as a function of different sorts of manipulation of class composition. replacing well-off students with low-income students on average, even small proportions of the class. And finally, at the very bottom, getting down to the calculated and predicted change in classroom performance that could be obtained by replacing a highest quintile teacher with a lowest quintile teacher in the spirit of value-added measures of teacher performance, which is where I began. So to think that you're going to succeed in getting the computer programs to separate good teachers from bad ones and get the good ones to raise student scores, you have to believe that you somehow control for a lot of really bigger stuff really, really well so that you can take this effect out of that effect.
So we had another question here about Head Start, and wondering whether you have ever looked at Head Start versus equally poor non-Head Start children's performance over time. And the comment is that this person has heard it's the only thing that makes a difference for poor kids.
So I believe these are the Perry High Scope studies, which I've read and which are quite impressive. They do indicate a really, really long-lasting impact of a very well-done preschool on a whole range of student outcomes years down the line. I wouldn't agree it's the only thing. One of the things, I realize we only have a minute or so left, but I will, here we go. Here's Texas. It's one of the other things I could have shown you, and so I will zoom on into it. I think there may be many things that make an impact, but we don't always measure them. So I'm going to focus in on the low-income students. There was an initiative in Texas. It was costing about $140 million a year that started operating in the early 2000s and lasted till around 2009. It contained a couple of different moving parts that basically consisted in making passing math exams high stakes for students because they wouldn't advance in grade if they didn't do it, and gave teachers a lot of support and training, and let students take exams multiple times. What the red curves show are student trajectories after this was put into place, and the blue curves show student passage through grade and score. On the vertical axis here is score on mathematics exams. The horizontal axis is grade, and I've literally followed cohorts of students. So low-income students moved up by a huge amount right after this initiative was put in place. Not enough to completely compensate for the differences between low-income and well-off students, but it reduced the incidence of failing mathematics really quite remarkably, and it nearly doubled the number of students who were getting sufficiently high scores on this mathematics exam that you would say that they are on a college preparatory track. I don't have time to discuss why I believe this particular initiative has its fingerprints all over these changes, but several different things you can check. I would say that seems to be something that worked. And you can look at the gains of scores of low-income students across the United States and say there are other things that are working. So the fact that we haven't managed to completely erase the differences between low-income and well-off students shouldn't divert us from the fact that everybody has been doing better. And teachers have been working very hard. Many things have been improving. From that point of view, there's actually considerable grounds for optimism.
All right, and then on that note, I'll just say it looks like we're out of time. And thanks again, Michael, for your informative presentation. And I'll hand things back over to Crystal with the note that one of the questions we didn't get to, which is, will this presentation be available afterwards? And Crystal, I think you're probably in the best position to answer that.
Well, it's already online for you, at least the Prezi is.
Okay, yeah. So here's what we'll do with that. There will definitely be a recording available of this presentation. And Michael, probably what we'll do is if we can put the link to this presentation on the webinar page for this webinar, which hopefully most of you found, and I think you'll be directed to it after you leave the webinar today, actually. It's on the APS webinar site, and we'll put a link to this presentation there. And if any of you have trouble finding it, email me, webinars@aps.org, and I'll be happy to send you that information. Like I said, this is all the time we have for the official webinar. I don't know if you guys have a few more minutes or if you feel like we should stick around. If anybody wants to continue the discussion for a few minutes after wrap-up, that's fine with me. So it's up to you guys. But before we make that decision, for those of you who are signing off now, please remember to actually fill out the survey when you leave, because it's really important for us, information for us to keep improving our webinar presentations. And I guess that's all I have for those of you who are leaving. Thanks very much. Monica, were there any other questions that you wanted to address?
Let's see here. I think we got through many of them, but there were a couple more here. Let's see. One question here was, do you know of any good statistics that describe low-income schools in terms other than college prep? For example, how many students get a job out of school versus students who don't finish school? Also, after all, many poverty-affected students might not be in a position to continue into post-secondary education, but high school education is still beneficial.
I think that's a really great question, and I don't know the answer. But now I'm curious, and if I can figure out any way to address it, I will. And I'm glad it wasn't asked during the regular presentation.
Yeah, actually, and I think most of the questions are done. I actually had one follow-up question myself, which I found your motion graph of the NAEP data, where all the states were increasing in student scores, really interesting. And of course, as a physicist, I had to ask the question, are we seeing actual real increases in student performance, or is this the kind of thing, where on state exams, the average scores are adjusted to, to basically so that the states have enough students who are passing, show like they're passing. It's more of a political thing than anything else. And so I'd be interested to hear your take on what that actually means when we see the NAEP data changing and increasing from year to year.
Okay, so two responses. First, on the question of NAEP, it's a samples exam. It's not high stakes for students, teachers, or anybody else. It's professionally put together. I've seen no reason to think that anybody is gaming it, or that anybody who administers the exam has been watering it down to give in to political pressure. I guess it's possible, but I've even talked to people who've been pretty high up at NAEP, and they've been adamant to me that nothing of that sort has ever gone on. So, I mean, you can always wonder that, and there could turn out to be some inside NAEP story, but particularly since the public doesn't even know this is happening, it makes it seem very unlikely it was done for political gain, because there sure hasn't been any political gain, because it's not even known. On the state exam,
right? Yeah.
I would differ with you a little bit. Different states have definitely set different thresholds. So you can compare different states and try to cross-calibrate what they do as passing or proficient, but there are very wide varieties of that. And then the schedule by which they get to 100% proficient by 2014 is all over the map as well. But that I don't think there's much evidence, though, that in the middle of the year, states are sort of watering things down to make things look good. They've got some schedule, and they're kind of sticking to it. Texas has been particularly accused of watering things down because the proficiency standards in Texas are low compared to those of other states. And that's why I find it particularly interesting that when you look at NAEP, Texas has risen to the top in NAEP scores for low-income kids. So even if we did set low thresholds, we're still blowing the top off of that test. That's interesting.
Mm-hmm. And then a follow-up on that. I also was interested to see that we see steady growth in elementary and middle school with the NAEP scores, but it looks like the high school scores are kind of stalling out. And
yep.
Do you have a sense of why do you think that is?
Well, data become much more sparse, and even the numbers of variables you can check with high school test is much smaller than what you can check with middle school test. So unless other people can help me out, I have to guess. But I think it may well have to do with the fact that as you get towards the top of high school classes, you just can't offer it because you don't have the qualified people to become more and cross-chatter between successive webinars, I just looked at the Common Core standards, and it looks as if they're sort of lowballing things for the end of high school. So I'm not sure that they're going to be driving this up.
Okay, well, I think that's about it for the questions. Thanks very much, Michael.
Great.
I, again, really appreciate the tour of the data, and I'll turn it back over to Crystal.
Okay, great. Thanks, Monica. I want to echo Monica's sentiments. Great presentation, really interesting. Thanks to Monica for doing a great job, and Michael for doing a great job presenting. All right, so we hope you'll join us next time.
And thanks to Crystal.
Bye,
You did a
everybody.
great job organizing these things.
Oh, thanks. All right, thanks, everybody. Bye-bye.
Bye-bye.
Bye.